All right, this is your Unit 4 review. So we'll do a few examples. There will also be a few more examples for you to try. Again, the answers are provided. I strongly encourage you to try it on your own first and then check your answer. It is strongly encouraged that you look at this and that you do this. It will help you on the test. So we started this unit quite a while ago, and we started graphing quadratic functions. So if we take a look at our first example here, we have the function y equals negative x squared minus 4x minus 5. So the first thing that we have to do is we have to find the vertex. So to find the vertex, I'm going to do the x coordinate first, and then I'm going to do the y coordinate. So coordinate. So without factoring, which again, we've learned how to do later and those types of things, but just to find the x coordinate, you can use the formula negative b divided by 2a. So in this problem, a is negative 1, b is negative 4. So if I plug those in, I'm going to get negative 4 over 2 times negative 1. So negative 4 is 4, 2 times negative 1 is negative 2, which tells me that my x coordinate is negative 2. So again, your vertex goes x comma y. So I know that my x coordinate is negative 2. And I've got this super nice equation that, hey, if I want to find the y coordinate, all I need to do is take my formula and plug it in. So every time I see an x, I'm going to plug in a negative 2. Negative 2 squared minus 4 times negative 2 minus 5. Negative 2 squared is positive 4. Keep the negative on the outside. Negative 4 times negative 2 is positive 8 minus 5. Negative 4 plus 8 is 4 minus 5, which gives me negative 1. So my xy coordinate is going to be negative 2, 1. So let's just graph a little bit of it. X is negative 2, y is negative 1. So that's going to be right here. Because this was negative, I know that it's going to open down. And then my axis of symmetry is going to be on my x-axis here. Now, a point of emphasis that people did not necessarily do, you need to not just draw it, you need to have a label. So again, this is a vertical line, and this is the line x equals negative 2. This is my axis of symmetry. So now I got to figure out, okay, I got to find at least one other point. So I can either move to the left or to the right. I want to find out what in the world does this equation equal when x is negative 1. So I'm going to plug in x equals negative 1 into my equation. And I'm going to say, okay, y equals negative 1 squared minus 4 times negative 1 minus 5. Negative 1 plus 4 minus 5. 3 minus 5, negative 2. So when x is negative 1, y is negative 2. And again, because of the axes of symmetry, I can move it. So again, I count this is 1 unit away. So I can go 1 unit away as well and plot that right here. So I'm getting close. I know it opens down, and I know that I've got 2, but I need to get at least one more. So I'm going to choose the point x equals 0. And that's going to be real easy to calculate. So again, if we plug it in, y equals negative 0 squared minus 4 times 0 minus 5. 0 minus 0 minus 5. So I see that when x is 0, y is negative 5. And again, if I have that on the right side, when x is, let's see here, 1, 2, I know that it's going to be mirrored on the other side because that is how an axis of symmetry works. So I have now graphed 5 points on my graph. I need to label my vertex, which I did. I said my vertex was negative 2, negative 1. Again, I have a bunch of work here, but vertex equals negative 2, negative 1. I calculated 1 point, I labeled the axes of symmetry, and I should be good. So again, you can try 3 problems right here. We are moving on. Another way I could have found this y-intercept is, again, looking at this last point right here. I knew that it was -5, 0, -5. Okay, quadratic functions in vertex or intercept form. So looking at this form, okay, if I want to graph this function, these two numbers are going to be my x-intercepts. However, remember our base formula is x minus p, x minus q. So it's actually kind of flipped. So again, because it's x minus 4, that's going to be a positive 4. Okay, so x is 4, y is 0. And because it's an x plus 2, my answer is going to be -2. So that's one of those goofy things. Because our formula is a x minus p, x minus q, to fit that x minus, if I plug in a positive 4, it's going to be negative in the equation. If I plug in a -2 and I subtract it, x minus a negative turns positive. So I know that that's true. I know that because of my, because it is a positive, there's no number out here, that means it's positive. So I know that my graph is going to open up. And then to find the vertex out of this form, I have to take these two values, add them, and divide it by 2, because my vertex is going to be in the middle. So this gives me my x coordinate, -2 divided by 2. So my x coordinate is going to be -1. Oh, excuse me. See, that's a very simple mistake. I plugged in the wrong one. So again, this should be positive 4. We talked about that. This is a positive 4. And then the y, or this one is the plus -2. So this should be a positive 2/2, which gives me a positive 1. And then you just plug in x equals 1 into your equation and solve it. -3 times 3 equals -9. So when x is 1, y is -9, it opens up because it's a positive a value. Again, they should have labeled this axes of symmetry a little better. They should have said x equals 1. So here's some examples for you to try. Okay, again, please try these on your own until you feel comfortable graphing them. If you get a squared number like this, again, rewrite this as x plus 8, x plus 8. And you still have -3 on the outside. That's one way. You can also use vertex form. And there's your answers. You can check your work. Then we talked about factoring. Okay, so factoring, when we have an a value of 1, we like. So x squared minus 13, x squared minus 13x minus 48. Again, it's got to equal 0. We talked about a factor x. So again, we have the base function ax squared plus bx plus c. So we want two numbers that are going to multiply to equal c, but add to equal b. So this is what I'm trying to plug in here and here. What two numbers multiply to equal -48, but add to equal -13? So I can start by listing out factors of 48. Say 1, 48. No, that's probably not it. 2, 24. No. 3 and 16. Hey, that might work. Now, the only way to have it equal a negative number here is if one of my factors is positive and one of my factors is negative. But because it has to add up to -16, I know that, or -13, I know that that 16 has to be negative, because -16 plus +3 equals negative 13. And negative 16, what just happened? Negative 16 times 3, hopefully it's still there, is going to give me, we were doing too good at math. Negative 16, positive 3, adds to get negative 13, multiplies to get negative 48. So if I were to factor this, I would say, okay, x minus 16, x plus 3 equals 0. But then you need to use the zero product property. So again, it's like it's opposites. Our question is, what would make this equal to 0? Well, that's x equals 16. What would make this equal to 0? Well, that's x equals negative 3. So my answers are x equals negative 3 and x equals 16. Factoring is huge, okay? We got to be able to factor. So again, there's more examples here. Try not to look at the answers, but again, check your work. If you're not sure how they got one, let me know. Now, these ones are a little bit different because notice our A value is not necessarily a 1. So up the examples above were all A values of 1. This is not. So my thinking is going to be relatively similar. I believe when we did it, we did kx minus m and k or lx minus n. So again, I need k and l to multiply to get negative 30. K times l equals negative 30. But I need n and m to add up to 12. Now, one thing you always want to look for is to say, is there anything in common that we can factor out? So what does negative 30, 9x, and 12 have in common? They actually have a 3 in common. And we're going to divide by a negative 3 to kind of get rid of that, negative sign. So I'm going to divide this by negative 3, negative 3, negative 3, and anything 0 divided by negative. That's not going to change. So I'm going to be left with 10x squared minus 3x minus 4. And so these are going to change slightly. This is going to be 10. And this is going to be negative 4. So we've got 10 and negative 4. Oops. So I know that the things that multiply to get 10 are 5 and 4, or 5 and 2, 1 and 10. And then the things that multiply to get 4 are either 1 and 4 or negative or 2 and 2. So again, it's kind of like, if you're not sure off the top of your head, you can kind of just pick them and see if you get close. So let's try 5 and 2 for k. So I'm going to say, okay, I think 5x something goes here and 2x something goes here. And then I said, okay, I've got 4. I can either choose 1 and 4 or I can choose 2 and 2. So again, I'm just going to pick one and try it and say, hey, I think it's going to be plus 2 minus 2. So then you start factoring to find out. 5x times 2x, 10x squared, negative 10x plus 4x minus 4. 10x squared minus 6x minus 4. No, that's not right. Okay, I tried it. I guessed. I didn't quite guess right. Let's try again. Okay, maybe I want to try 1 and 4 this time. So I'm going to try 1 and 4 this time. And I'm going to say, okay, what about if I tried a negative 4 and a positive 1? 5x times 2x is 10x squared. 5x plus 1 is 5x. Negative 4 times 2x is negative 8. Oh, that's looking good, because when I combine like terms, when I combine these like terms, I'm going to get 10x squared, 5 minus 8 is negative 3x minus 4. That's what I started with, okay? Now that's not our answer though. That's how we check our work. Our answer is 5x minus 4, 2x plus 1. But we got to set each of these equal to 0. This whole thing was equal to 0. So what would make 5x minus 4 equal 0? Well, that would be add 4, divide by 5, 4/5. Or what would make 2x plus 1 equal to 0? That would be subtract 1, divide by 2, x equals negative 1/2. So those are going to be my two answers. In my mind, factoring when you have a number that's not 1 up front can sometimes be the most difficult. Okay, finding square roots, we can do this. So 4x minus 7 squared equals 80. First step is get rid of this 4, so divide by 4 on both sides. X minus 7 squared equals 20. Again, to undo x minus 7 squared, you take the square root of both sides. Now, we don't necessarily know what that is, okay? But we have x minus 7 equals the square root of 20. And then you are going to add 7 at the end, plus 7. And remember, square roots have positives and negatives. So this is a positive and negative because this square root of 20 times the square root of 20 gives you 20, or negative square root of 20 times negative square root of 20 still gives you positive, okay? So we got to remember to do that. So x equals, I can simplify the square root of 20 to be the square root of 4 times the square root of 5. So 2 square root of 5 plus 7. And again, don't forget that square roots have two answers. This is positive 2 square root 5 plus 7 and negative 2 square root 5 plus 7. So it looks like they just put the 7 in front. That is kind of standard, is to put that number in front. So again, you've got examples that you can try here. Again, try them on your own. Make sure you get the same answer. Then we talked about complex numbers. So again, complex numbers are when we use that imaginary number I. It happens when we take a square root. So we are going to 6 minus 4i, 1 minus 3i squared. Do it right here. So 6 minus 4i, 1 minus 3i. So we're going to multiply it. Take my first term, multiply it by both terms. Take my second term, multiply it by both terms. 6 times 1 is 6. 6 times negative 13i, or 3i is negative 18i. Negative 4i times 1 is negative 4i. And this is the important part, is negative 4i times negative 3i is negative 12i squared. Now remember, I is the square root of a negative number. So we could call it negative 1. But when you get I squared, it is like the square root cancels each other out, and you are just left with negative 1. So I'm going to substitute this I squared for a negative 1. 6. Negative 18 minus 4 is negative 22i. And then we're going to rewrite this as negative 12 times negative 1. And then a negative 12 times negative 1 is plus 12. 6 minus 22i plus 12. And of course, we can combine, we're almost done, 6 plus see here, I must have, oh, I see. Right here, negative 4i times 3i is a positive 12i. And then when I add in that negative, then it becomes negative, or positive 12 times negative 1, it becomes negative. And then 6 minus 12 gives me negative 6 minus 22i. You must put the real number first, okay? This is standard form. Real number, then imaginary. That's how we have to write those numbers. So again, you've got more examples. You can try these on your own. Last kind of section here, using the quadratic formula. Remember we had that silly song, x equals negative b plus or minus the square root, okay? So you have to set it equal to 0. So -2 to move that is going to be +2. A equals 3, B equals 6, C equals 2. So when I plug this into my formula, I'm going to get -6 plus or minus 6 squared minus 4 times 3 times 2. You got to simplify. So again, that would give me 36 minus 12 times 2 is 24. Stop it. Okay, 36 minus 4 gives me, we'll just keep going here. So -6 plus or minus the square root of 12. 2 times 3 is 6. So I see that, hey, I can simplify. -6 divided by 6 is just going to give me a -1 on top, or we can split it up. -6 over 6 plus or minus the square root of 12 can be simplified to be square root 4 times square root 3, which is 2 square root 3. So then we have 2 square root of 3 over 6. -6 divided by 6 equals -1. And then we have plus 2 over 6 can be reduced to 1 over 3. And then we also can't forget we have -1 minus 1 square root 3 over 3. So again, I would prefer that you split this up because again, you can cancel those out. -1 plus square root of 3 over 3 and -1 minus square root 3 over 3. Again, there's your few problems you can try on your own. Good luck. Let me know if you have any questions.